Get your math on.
Get your math on. Get your math on.
Get your math on. Get your math on. Get your math on. I'm trying to find the help you with this problem. We're trying to find the area of this. Let me get something to write it down. But they gave it to me in inches, unfortunately. So there's this rectangular park playground, and we're trying to find out because we want to put some recreational carpet down for the children to play on, but they gave the dimensions in inches. I don't know why they did that. And so now I have to multiply to find the area. I remember it's length times width, so that means I'm gonna have to multiply that 365,410 times 156,004. Good Lord, how am I gonna do that? I gotta get my calculator. Let me punch that on the calculator and see. Then I gotta change it to feet because when I go to Home Depot or Menards, it's gonna be in feet, the amount that I need. Oh, crap. Let me see. Let me punch it on here and do it. Okay. So they're telling me I have an area. It says my calculator says 5.700542164 and then E10. What in the world is E10? The heck is that talking about? How am I going to have E10 in the area of the playground? Oh my goodness, what the heck is this, man? I can't go to the store, Home Depot, and say I need 5.700542164 E10 square inches of recreational carpet or whatever. What the heck is this? Somebody help me. I need somebody that can understand what the heck this is talking about. Please, is there anyone that can help me out here? I'm kind of lost here. What the heck? What is the E to the 10 on the calculator? That's what it says on my calculator. What are we talking about? This is crazy. This is ludicrous. Yes, we can do that. Yeah. I'll get back in a minute. I got a call. Yes. Did someone ask for help with interpreting a big number with an E or something in it? Did I hear someone make a call for help in the area of mathematics? I am here. I have arrived. The Math Doctor is here. Welcome to another episode of What Should We Be Doing at This Time? Get your math on. That is absolutely correct. In this episode, we want to talk about that large number that the person that called me got and what the E in the calculator meant. That E on the calculator is dealing with scientific notation. When the number gets extremely large or extremely small and has a lot of digits, they come up with a notation in order to represent it called scientific notation. So if he would have known his scientific notation and if he would have got his math on, he would have known that that number that he was looking at on his calculator was just written in scientific notation. So we want to quickly in this episode look at this notation called scientific notation. First, let's look at what is the notation in the first place. How do you write a number in scientific notation? Well, the format for scientific notation to get your math on looks like this. Bounce with it. And one more time. And bounce with it. Thank you very much. I like bouncing with it. Okay. First, you have to have a number between 1 and 10. In order to write in scientific notation, you have to have a number between 1 and 10. Then you have the times because you're multiplying by a power of 10. And our decimal system is based on 10. So whenever you move it to the right a decimal place, you're multiplying by 10. Whenever you move it to the left, you're multiplying by a power of 10 with a negative exponent. So positive exponents of 10, you move to the right because you're growing. Negative exponents of 10, you move to the left on the decimal system because you're decreasing. It's like 1/10, 1/100, 1/1000 when the exponent is negative, okay? So this is the format for scientific notation. You have to have the right exponent, and you have to make sure the number is between 1 and 10, all right? So let's look at some examples of writing in scientific notation. Here's a number here. Good Lord, that thing is large. That takes up too much space. Imagine if you had to multiply that by a bigger number like the fellow that called me in the first place had to deal with. He had two extremely large numbers that he had to multiply. So just writing them out is massive. So if you can express it in scientific notation, it makes life so much easier. So this big number here, we want to put it in scientific notation. The first thing we have to do is find the decimal point. Where is that decimal point? I don't see him. Where is he hiding at, huh? Let me get my glasses and see if I can find this decimal point. Does anybody know where it is? The decimal point, if you don't see it, is always after the last digit. All you got to do is think about writing this bad boy with money. Imagine if that was your money in a bank. Good Lord, I'd be a happy camper. But where would your cent part be in the money? It would be right here. The decimal at the end, and then you would put a 00 for cents. So when the decimal is not seen, it's after the last digit. So that decimal point was hiding from you is right down there, hiding, right? So now we want to move it. You got to move it. Where do you want to move it? My red arrow tells you. I want to move it so it becomes a number between 1 and 10. Where is that going to be? It's got to be between the 2 and the 3. That's the only way you can express this as a number between 1 and 10. So now you just count your movement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spaces to get it to be a number between 1 and 10. Don't count zeros, count spaces. Don't count zeros, count spaces. You count the decimal spaces because each of them is a power of 10. And since this is an extremely large number and my zeros are going to the right, that tells me my exponent of the 10 will be positive. So now check it out. The exponent of the 10 will be positive, and that would be my answer. You take all the significant digits, 2, 3, 4, and 5 are significant. The zeros you throw out because you're representing them with that times 10 to the 16th power. So since I moved it 16 spaces to get it between 2 and 3, then it's 2.345 times 10 to the 16th. Let's do another, because this is fun and exciting. Get your math on. How about this one? Express this number in scientific notation. Bam! Now, this is not as big as the other one, but it's big enough, right? We got to first find the decimal. Where is that decimal point hiding? Once again, it's at the end of the what? Number. The last digit in the number is the decimal point, so it's right here. Where do you want to move it? The red arrow tells you. I want to move it between, so it becomes a number between 1 and 10. That has to be between the 9 and the 2. Has to be between the 9 and the 2, all right? So now let's see. Bam, that's where I want it. The arrow marks the spot. So we got to count how many spaces to move that bad boy from where it is to between the 9 and the 2. Count with me, please. 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. And this, again, is an extremely large number. How do you know? The zeros are to the right of the significant decimal. Numbers. It's to the right. So this bad boy is going to have a positive exponent. Y'all mean? Yes, positive exponent. So let's clear this so you can see the final answer would be, bam, There it is right there. Whoop, there it is one more time. Whoop, there it is one more time. Whoop, there it is. All right. 9.25 times 10 to the 8th is our answer. Okay. Next one. Now let's do an extremely small number because they exist as well. Bam, look at that right there. You notice it's an extremely small number because now the zeros are to the left and you are in the decimal world. And when the number is extremely small, you don't have to find the decimal point. It's going to be in the number because you can't write the number without the decimal point because you're in decimal land, decimal world. This number right here, I'm going to show you how small it is. It's tens, hundreds, thousand, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion. This is 124 10 billionths with a THS. That's like have 10 billion of something and take out 124. That 124 is not even going to be missed because it's so small. 124 people in a sea of 10 billion. You can barely find them. That's how small this number is. Now, we want it to be, once again, scientific notation has to be a number between 1 and 10. So where we got to put the decimal, the arrow marks the spot. It's got to be between the 1 and the 2. Between the 1 and the 2. So now let's move it. You got to move it. You got to, okay, we get it. All right. So now I'm going to move it so it's between 1 and 2. 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. Just like the last problem, but however, this is not an extremely large number. This is an extremely small number. This bad boy is microscopic. I need glasses to see it. I need a microscope. So that means my exponent for the power of 10 is not going to be positive this time. It's going to be negative. Because now I have to move those decimal places to the right to get it to a number between 1 and 10. That means the zeros are over here. That means I'm in decimal world, fraction world. I'm not whole. I'm a little fraction, a little decimal. That's how I write it in scientific notation when the number is extremely small. Look at this here. This is going to blow your mind. The weight of an atom. I got atoms on my hand, but I can't even see them. Where's those atoms? Where are those atoms, right? Even on my pinky finger, there's atoms. I can't see them because that atom is so small, its weight is infinitesimally small. We're going to write it in standard numerals. So now we're putting it in reverse. Yeah, I mean, we're putting it in reverse. We've given it to you in scientific notation, and we're going to write it as a standard number. That bad boy is going to be extremely large. It's 9.104 times 10 to the negative 31 kilograms. Good Lord. How do you do that? Express as a standard numeral. The first thing you do is you take the decimal point and you're moving it 31 spaces, but now you got to find out what direction. We're going to go 31 spaces to the left because it's a negative exponent. That means those zeros are going to be to the left of the significant number, making it smaller and smaller and smaller. So I'm going to write it to the right, and bam, there it is right there. You have to move that decimal place 31 places to get it between 9 and 1. So I go 31 spaces the other direction. Right? Watch. I'm here. 1, 2, 3, 4, 5, 6, 7, all the way till I get to the end. 31 spaces. All right? 31 spaces. Should have used yellow. I'm moving that bad boy 31 times. All the way until I get to the end. That's how I write it in scientific notation there, buddy. Now, that's an extremely small number. Good Lord, that's an extremely small number. All right. So let's do this one. Express this as a standard numeral. I start with the 3.45 and I go to the left. And I move that decimal to the left because it's a negative exponent, 6 spaces. 1, 2, 3, 4, 5, 6. A decimal point's right here. Add zeros wherever you see for placeholders. That's how we do that one. Extremely small number. And it will look like this as an answer. Bounce with it. Bam. One more time and bounce with it. What about this one? Expressed in scientific notation. Boom. I find my decimal point. It's right here. And I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces to put it as a number between 1 and 10. That means my exponent is going to be positive, and it will be equal to the number of spaces I move. Bounce with that one as well. So, family, scientific notation, we cannot stress how important it is in astronomy and engineering and computer science, so many fields where you're dealing with either extremely large numbers or extremely small. Please get your math on and learn more about scientific notation. See me for the next episode. Take care, fight the power, do the right thing, and what? Get your math on. Take care. Peace out. Till the next time.
Get your math on. Get your math on.
Get your math on. Get your math on. Get your math on.
Get your math on. Get your math on.
Get your math on. Get your math on. Get your math on.